Hello, everybody, and welcome back. In Unit 3, we are going to continue our study of derivatives by studying more complicated derivatives. The question we're going to ask ourselves today is, how do you take the derivative of a composite function? And you may want to grab some colored pens or pencils for this lesson because I've got colors all over the place. Just to review, a composite is created by plugging one function into another function. The composite of f and g is denoted by f of g of x or f of g of x. And it's the chain rule that is used to differentiate composite functions. You ready to go? The chain rule. If f and g are differentiable, then the composite function of f of g of x is also differentiable, and that's the chain rule. So this is saying if we're going to take the derivative of a composite function, what you do is multiply the derivative of the outside function, keeping the inside the same, by the derivative of the inside function. First, I want to show you kind of a simple one with and without the chain rule. Without the chain rule, well, you could do this right now. If you have f of x equals 5x plus 3 squared, first thing you'd have to do is expand it, multiply it. Now you would take the derivative of each of these terms separately. So the derivative of 25x squared is 50x, derivative of 30x is 30, and the derivative of 9 is 0. Now let me show you with the chain rule. So here's our function again, and we've got to figure out, like, what's the outside function, what's the inside function? So the outside function is something squared. Well, what's being squared? 5x minus 3 is being squared, so that's the inside function. So I've colored it here so you can kind of see the outside function and the inside function. I think that should be green. So when I take the derivative, I start with the outside function. I'm going to bring the exponent forward, drop the power by 1, keeping the inside the same. So I've got the derivative of the outside function. Now I'll take the derivative of the inside function. So the derivative of 5x plus 3 is 5. Got the derivative of the inside function. So if you clean it up a bit, you can see that these are the same answers. Either process works. However, there are some times when you have to use the chain rule. Before we dive into some of those have to use the chain rules, though, let's practice one more of these. So do we have an inside function and an outside function? Inside function is 4 minus x squared, and the outside function is something cubed. All right, so taking the derivative of the outside function first, the exponent comes forward, and then we drop the power by 1, keeping the inside the same. That's the derivative of the outside. Now we can take the derivative of the inside. So the derivative of 4 minus x squared is negative 2x. And if you want to clean that up a bit, that's what it looks like. Ooh, what do we do with these? Anytime you see a radical, the first thing you need to do is rewrite that as a fractional exponent. And actually that helps us see the outside function and the inside function, doesn't it? So we will go ahead and bring forward the exponent, drop it by 1, drop the power by 1, and then take the derivative of the inside. So the derivative of x squared minus 1 is 2x. All right, next one. Let's take this fraction and change it into a multiplication problem with a negative exponent. So we'll bring the exponent forward, multiply it by -7, keep the inside the same, drop the power by 1. So -2 changes to -3. Now we can take the derivative of the inside, and the derivative of 2x minus 3 is 2. Okay, we're diving into a complicated one. All of the ones we've done so far had 2 functions. This one, well, it's got more than 2. Let's check it out. If you see something complicated, the first thing you do is stop and just identify all the functions you see. So the first thing I see is the outside function, something cubed. Well, what's being cubed? Well, it's the cosine of something that's being cubed. The cosine of what? The cosine of e to the something. E to the what? E to the 5 theta. We have 4 functions, so we're going to take the derivative 4 times. I've rewritten it so you can see the outside to inside functions, and let's go. The outside function first, exponent comes forward, drop the power by 1, keep all the rest of it the same. Outside is taken care of. Now the next one you can see in our list of functions is cosine. So we'll take the derivative of cosine, which is negative sine. Keep everything else the same. And the second function is taken care of. Next function in line is e to the something. So that's e to the 5 theta. We'll take the derivative of that. The derivative of e to the x is just e to the x. So we're just going to rewrite e to the 5 theta. And we've got the third function taken care of. And finally, the derivative of 5 theta is 5. So we've got the fourth function taken care of. We did it. There was a lot going on, but I want you to just be very organized and keep track of your functions. G of x equals cosine squared 4x minus sine squared 4x. Well, let's stop first and identify all the functions we see. First thing I notice is that we actually have 2 problems in one. Within those 2 problems, we have some composite or nested functions. So pause the video a sec. Can you find how many functions you need to work with? I see 3 here. There's the outside function squared, and then there's the cosine of something, and then the 4x. So there's 3 functions on that one, and then still for sine squared 4x, 3 functions there as well. So pause the video again, see if you can come up with what the derivative would look like. So this first part here is the derivative of cosine squared 4x. Derivative of the outside function, bring the 2 forward, keep the inside the same. Then the derivative of cosine is sine, and the derivative of 4x is 4. And then sine is going to look pretty similar. The derivative of sine squared 4x, we've got the exponent coming forward, keeping the inside the same. The derivative of sine is cosine, and the derivative of 4x is 4. Let's get a little bit more complicated. Again, the first thing you do is identify the functions. So here's what I've identified. X to the 4th times sine squared of x. Now look at this. We have 2 functions being multiplied together. So we need the chain rule and the product rule. You ready for this? Here's the derivative. Okay, using the product rule, we take the derivative of the first, which is 4x cubed, times the second. The second just stays the way it is, plus the derivative of the second. Now this time we need to use the chain rule. So we've got the derivative of the outside function, keep the inside the same, times the derivative of the inside, so the derivative of sine x is cosine x. So that's the derivative of the second term, and then multiply that times the first. So do you see we've got derivative of the first times the second plus derivative of the second, using the chain rule, times the first. You might need to just let that one brew for a second. Let's move on to our last example. I thought it would be fun to end with a tangent problem. So again, we're going to first identify the functions we see and change the radical into a fractional exponent. I see three functions here: tangent, and then something to the 1/2, and then 2x minus 3. So we'll do the outside first. The derivative of tangent is secant squared. Keep the rest of it the same. Then the green function, something to the 1/2, we'll bring the 1/2 forward, keep the inside the same, drop the exponent by 1, and then finally the derivative of the inside. And if you really want to clean that back up and put the radicals in, this is what it would look like. So that's the chain rule. It's really important that you fully understand the chain rule. So please practice, practice, practice. If you want to watch this video again, also a great idea. Thanks for being here. See you next time.